All right, cool. Super. Here's where we are. Good to see you all. Hope you're having a great week. Let's rock for our final time together. Don't forget, our final exam is not on Tuesday, it's on Thursday. Got the wrong slide up there. So just disregard that. We'll get back on track. I have the wrong slide deck up there. Let me just make sure. All right, it's good enough. Okay. So we know when our final is. It's next week, 10:15 to 12:45. Here's where we are today. We're going to go through WeDrive and some other things. Tomorrow, I'll have your classroom interaction and participation assessments up. Talk some more about reading day in a second, and we'll talk more about the final exam. Okay, reading day reps here in gray is what I have booked. So I still have a few slots available. Don't be intimidated by this if you wanted a certain slot or he's got no more time. If you want some reading day time, we'll make it happen. Just get hold of me at my email. Okay. Here's what we're going to do today. We're going to take a class photo here in a minute. And I'll tell you when we're going to do that so I don't like catch you by surprise, like with your mouth full of Lucky Charms or something like that. I want to talk a little bit real quickly. I have a few admin notes. We'll talk very briefly about tips on regression and then how to write confidence intervals. And so we'll get through all that pretty quickly. And then we'll jump into Joker's Wild and spend the bulk of our time there, getting as much done as we can. And then we'll close out the course with I've got a few comments, things I'd like to share. So, any questions before we begin, big or small? All right, super. So what I'm going to do is I'm going to screenshot the Zoom of all of you. So if you want to, I think I've got everybody on. If you want to be in the photo the same way you would be in the class, to just make sure your video is on. Okay, and let me get my quote camera set up. All right, on 3, 1, 2, 3. Oh, Max, you came in right at the last second, you joker. Let's try it again. All right, 1, 2, 3. Say for Max. All right, super. So I'll post that on the gram later today, and I'll post it on Canvas, and you can have that. So in 20 years from now, you can be like, what was that knucklehead's name? Or what was that person's name I did my project with? Or what was that whatever? All right, you'd be surprised how cool these things are to have. All right, so a few things off the bat. All right, so I I want to spend about 30 seconds on this. You all were warriors before you came in this class. You're even more of a warrior now. Keep your spot in Valhalla. What does that mean? Well, Valhalla is where all the warriors go once they die. They all go in the great Valhalla and they drink beer and they talk about all the great times, and they probably got some kind of Fight Club weird thing going on. All right. But the point is, if you go to the dark side, you lose your spot in Valhalla. So if you are thinking about, or you know someone who is thinking about on the final, hey, it's Excel, I'll just do my stuff and then I'll share it with my friend and they can submit it for their work, or maybe they'll give me a solid and they'll give me their Excel packet. Please, if you're even thinking about that, or you know someone who's thinking about doing that, talk them out of it. Okay. Or come talk to me. All right. We have other options than that. Once somebody goes to those options, my options go from here to here. And I have ways I can tell if this is going on. So just stay away from the dark side. Keep being a warrior. Keep your spot in Valhalla. That's all I'm going to say about this. It's an open book, open note exam, but do your own work. Okay. Just stay away from the dark side. All right. And you want to fix the bugs. If you've got any bugs in your system, meaning if you've sent me something in the past that I couldn't read, you got some kind of weird version of Excel, some kind of Google Excel kind of back alley, something from, I don't know, just, fix that stuff. We still have a week. You've got time to fix that stuff. If you want to do a test run with me individually, then let's do that. Here's a link. I don't make any money off of this. You can go to this link today and be like this kid here. He's probably hacking into my system right now, going to Zoom bomb us here in about 30 seconds. But he's the kid they have on the website. So this is the link that it's free for students. I mean, I think you set up an account and you'll have it like in 30 seconds, like your own version of Excel, Microsoft, and the other suite. And I don't get paid to endorse this. I just share it with you because I'm kind of thinking it'll make your life a whole lot easier. But just make sure your stuff is wired for sound. I mean, your computer and all that other stuff. YCP has the ability to loan computers. I just had a warrior from another section. He said right after class ended that his computer crashed. I emailed the help desk and I'm like, hey, what can we do with this? And they're like, we can get this guy a loan computer, even though he's out of state. So we have options. Just, it's just like going into combat. Don't wait to the day of to make sure that your weapon fires. Fire your weapon now. Make sure that stuff is tight. All right. Let's talk about regression real quickly. This came up the other day, and I know this was a little bit of a sticking point for some folks. Here's 3 ways that you can detect which variable is independent and which variable is dependent. And we know that we want to identify that so that we can figure out what's X and what's Y, because when we load values into the slope function in Excel or the intercept function, we have to load the Y values in first. So if we get this stuff mixed up, technical term, juxtaposed, we'll have a bad day. We don't want to do that. So one way up here is if the narrative tells you that variable A is independent. There you go. Then roll with that. Okay. You don't need to figure anything else out. If variable A is independent, that means variable B is dependent. Okay. So that's one way. The other way is kind of the other side of that. So if the narrative tells you that variable B depends on variable A, then by default, variable A is independent. Okay. In that case, variable A would be X and variable B would be Y. And then finally, if the question asks you to predict variable B based on variable A, then variable A is actually independent. I have this wrong on the slide. Okay. So any questions on this? All right. And, it is an open book test. In theory, you could have this, kind of set up next to you when you're dropping science with Defiance next week. I I would do one better than that. I would kind of go over this, look at problems, look at it in context until maybe you don't need this anymore. Okay. But to each his own. And then finally, how do you depict the correct notation for confidence intervals and hypothesis tests on Excel? So we kind of had this last exam. I didn't get too hung up on it, but there's 3 ways that you can depict the correct notation, whether it's a confidence interval and hypothesis test. So one way, and I'm going to do it right now, is use the insert. So you go here to Excel, find an insert first, and then you're going to go over here to the equation. And sometimes for me, it takes tapping it a couple times. And then you're going to find this menu over on the left. I'm going to do this in a second. And you can scroll through the menu. If you're looking for your friend's PPOP, there's PPOP. If you're looking for population mean, there's that. If you're looking for the greater than or equal to or vice versa symbols, there are those. So let's just rock this here real quick. All right. So here I am. I think this is not as big as I can get it. That doesn't really help me on the menu. So I'm going to go here to insert and click on that. And then over here, my equation symbol is going to pop up. So I'm just going to click on the kind of the P-pop looking symbol. And I'm going to click on it. For me, it takes a couple times. See how this menu appeared over here? And there's those greater than or equal symbols. So let's say I want one of those. That should insert me down there. Why didn't it? Come on now. All right, so there it is. I may not want it there, but I can move it somewhere else, wherever I want it. And I can type in numbers around it. So I could also go back to that. And all I got to do, if you don't see P-pop, it's not going to be on the same page. You hit that little next menu over, and you've got both your P-pop and your population mean next to each other. So let's say I want the population mean, so it's going to insert right there. And fat fingers, I was going too fast, so I did a comma. That's sloppy. Slow down a little bit. There's that. So that's one way of doing it. Now you may say, right, but during the test, I'm going to be freaking out. I don't really like that. Okay, that's cool. You don't have to do it that way. You have two other options. You can, number one, spell it out, or one other option, not number one, but you could spell it out. So for example, you just write it all out. The population mean is greater than or equal to 0.45. Okay, you can type that on in. I'll give you enough space to do that. Or you could handwrite it like this and just take a separate screenshot of that, say screenshot, or you could get fancier and clip, paste it into your Excel or whatever. Okay, so there's three ways of depicting this correctly. This is for a hypothesis test. We also would want to do the same thing when writing a confidence interval. Okay, so any questions on anything we just covered? And again, like any other thing, I wouldn't wait till the day of to practice what I just showed you. Okay, because you see, even me, as I was talking my way through it, I had to click on things a couple times. I would go in there. I wouldn't spend hours and hours by any means, but I'd figure out, okay, which way do I want to do this that I feel comfortable with? So I'm not in an exam condition. I'm not trying to figure that out. I can focus my energy on the problem itself. Okay, so cool. So here we are inside of Joker's Wild, and I am not going to start with blinkers because I'm a little concerned about time. So I'm going to start with Wild World. We're going to start with Wild World. And if we have time, we'll come back to blinkers. But the reason I'm not going to start with blinkers is because we spent time on this kind of setup the other day. Obviously not this problem, but something a lot like this. So I'm going to save this for last. If we get to it, great. If we don't, then I think you'll be okay. But we're going to start here with Wild World. So let's take a look at this. Batman is concerned within Gotham, less residents may prefer the wild. Oh, I guess I need to back up a little bit. I'm sorry. So for those of you who haven't looked at this, this is Joker's Wild. In terms of the intro, Batman thinks that the Joker has poisoned Wild, and Wild is this hairspray that people use around the world, not just within Gotham City. And so he thinks that Joker has poisoned this hairspray. And so he needs to confirm or deny this belief so that he can mitigate the potential damage that might be caused. And then once again, save the people of Gotham City. Now, why people don't move out of Gotham? I mean, a lot of bad stuff happens there, but I guess a lot of bad stuff happens in New York and people still live there. So it's a little bit plausible. All right, back on track. And there's a little bit here, a little bit of Easter egg trivia kind of stuff of, how I came up with this problem in the first place. But actually, I wrote this before coronavirus. So that was kind of interesting to me. Anyway, so back to on task. So Batman is concerned that less residents prefer the wild than within the population. All right. It's not so much he's concerned that, but he's wondering if they do. He's suspecting if less people use wild here than in the world, I might have more time to find the bottles of wild and contain the problem. So really what he's doing is he's trying to figure out what's the extent of his problem that he's dealing with, meaning how many people use wild, and if less people use wild than people in wherever, California, then he might have more time, all right, to find all bottles of wild and dispose of them. So that's how he's entering into this. And so he knows that Wild headquarters claims that 45% of global consumers prefer Wild over other brands. Okay. And so along the way, he does a survey just to compare within Gotham. He surveys 100 Gotham residents and he finds that 76 prefer Wild over other brands of hairspray. Okay, so that's kind of our set as we begin. So Trent, why don't you start us off? What do you think is the null and alternative hypotheses? Let me get rid of this for Batman's examination of what's going on.
All right, so it's going to be a population mean.
Okay.
Because the percentage, 45%. And I'm going to say it's equal to the 76. And then the other one's going to be not equal to 76.
Okay.
Wait, the second one's going to be, it's going to be not equal to, not equal
Okay.
to.
David, what do you think about all that?
Wouldn't it be 45% because you're trying to prove or disprove that the Wild headquarters claim is actually accurate or not?
Okay. So you want to put 45% here?
Mm-hmm.
All right. I'm going to put it just a different way. Okay. And Justin, are we dealing with a population mean or something else? Thomas, what do you think?
I set the question population, so I'm not really sure if it's the population mean or not.
Okay. Alyssa, what do you think? Jack, what do you think? Go ahead, Alyssa.
I'm not really sure. I was saying the same thing. I don't know if it's population mean or not.
Okay. Kendall, what do you think?
I thought it was proportion because it's a percentage.
Okay. Kendall is on to it. Okay, so this right here, 45% of global consumers. All right, that's the proportion. Remember, it's like our pizza. We're not saying the whole pizza, we're saying a little bit less than half okay, of the whole pizza prefer wild over other brands. Okay. Now, Tim, what do you think about this symbology? Is this the symbology or the these mathematical signs? Do we want to go with these or something else?
From what I got, I was pretty sure that we would go with those because we're just either proving or disproving that it's 45%, correct? Or am I wrong?
So it's this less.
Oh, okay. I got you.
All right. So we really want. So based on that, Tim, based on that kind of me pointing this out, then how would you modify these?
Wouldn't the null be greater than or equal to, and the alternative would just be less than?
Okay. So that's our setup right there. Okay. And you know, that is worth spending time on. Whether it's this problem or others, just getting that in because it's the toughest part. All right. So to briefly review, like Kendall pointed out, 45% of global consumers. This right here is the status quo claim about the larger population. Now, this claim says equals, but because Batman is concerned about less than, the alternative would be less than, and then this would be greater than or equal to. All right. And again, we want to take this sample data and put it aside for a second. It's a little misleading that that's right there and not later in the questioning. Okay. But Batman has some evidence, but we're going to put it aside real quick and construct this first so we're not biased. Okay. So this takes us through Q1. All right, we're going to use a level of significance of 0.01 in the critical value method to examine Batman's hypothesis. You notice here that I didn't walk you through it anymore. I'm essentially kind of not throwing you into the pool, but I didn't ask you for the T stat. I didn't ask you for Z stat. I didn't ask you for anything like that. I just said, use this to examine a hypothesis, and then straight up I ask you for what is your conclusion. So Jack, how do we get started on this?
So what would it be? 45.45 would be on top. I forget it. I'm not sure.
Okay. All right. What do you think, Eric?
Would it be the 0.76 out of 100 minus 0.45 on top, and then divided by the square root of 0.45 times 1 minus 0.5 over the sample size?
Okay. So you said, I think I heard you say 0.5, but I'm pretty sure you meant that right there.
Yeah.
Okay, super. So what Eric is doing is he's using that formula for the test statistic when we're dealing with proportions. And so, Megan, what is the sample size?
I have this sample size as 100.
Okay, super. All right, so we're going to put 100 down there. All right, and when we do all that math, what do we get? I couldn't read that in a million years. It came out of my printer so small. Stand by. Chicken is not working today. I get that we get a Z stat of like 6.28.
I have a question about the equation.
Okay.
I have the equation down here, the denominator being the square root of the sample size times by the hypothesized proportion, and then times by the 1 minus the hypothesized, or yeah, hypothesized proportion. But then like this, it has a sample size in the like divided.
Yeah. So the equation you have is the same equation as this one.
Oh,
I actually have a video on this, Max. It doesn't appear to be the same equation, but it is. So, when you so just to write the equation, and I don't have the one memorized that Max is referring to, but this is the equation that we're using right now. Okay. And this is a T-stat equation. Okay, so Max's question is he's got this other one that I think it's written in terms of X. And so the equation you have, Max, is the same one. If we times this by N over N, we would get the equation you have.
I see what you are doing. Yeah.
All right. Now, the reason that I don't teach the equation that you're referring to is because to me, that one is more confusing. I've just chosen, but they're the same equation. They're in the book. I have a video on Canvas on this. So does that answer your question?
Yeah.
For
Thank you.
now, and for everyone else, if they want to use that equation, I'm just not going to write it out because I don't know it. I don't have it memorized like I do this other one. But whatever works for you. I guess the benefit of that equation that Max has is that you don't have to figure out what P is. But beyond that, to me, I don't know. I think it's potentially confusing. So I don't use it because I try to keep things as simple as I can for you. Okay, so we have this right here. And this is a T-stat. So Max, what do we do with this number?
You can plug that into Excel. It's one tail.
Okay.
So you would do the t dot dist, and then I think in Excel it would be either the degrees freedom first or the t stat. I forget which one it is, but it tells you, it highlights it, right?
Well, you tell me.
Yeah, it highlights it there. I forget which one's first though in the comma, but you enter in the degrees freedom, which would be 99, and then the t stat.
Okay, so what's the formula I need to use here?
What you
I
have
have
right.
the right formula?
That's what I would assume, yeah, because it's a one tail.
Okay, so don't assume. You're
Yes.
correct, but there's no need to assume. All right, so let's hear from someone else. We're on the right path. George, how would I finish this? What would I put in here? Well, first of all, should I be using this right here?
You'd put in your T stat first, and then your degrees of freedom, or Z stat.
So which is it? Hannah, which is it? Do I have a T-stat or a Z-stat?
I thought it was a Z stat.
Why did you think that?
Because it's critical value.
Okay, you're on the right path. It is critical value. But
Because
we
we're using a Z distribution.
Why are we using a Z distribution? Remember, just because I ask you questions doesn't mean you're wrong.
I'm not really sure.
All right, when we roll with P-pop, we roll with Z. All right, so for everyone, when we roll with P-pop, we roll with Z. That means we don't use the T distribution.
I think you threw me off when you said that was a t stat because I had looked at the z stat equation and then I was like, wait a sec, what?
Okay. All right. So let's hear from, so Greg, what do we do with this Z-stat score of 6.28?
Do you find the Z value?
Okay. And how do I do that? How can I do that?
Look at the Z table. And I think it's like 0.9999.
Okay. And what do I do with that 0.9999? Is that good, or do I need to do anything with it?
I'm sorry, I can't remember.
Okay.
The since it's okay, so it's do you accept accept the null hypothesis?
Okay. Well, we're skipping a couple steps here. So first of all, what's our critical values or critical value? How do we determine that? Let's hear from Lexi. What do you think?
So it's a one-tailed test, so you have to go to that values chart and use your level of significance to find what the critical values are and draw your reject and do not reject regions.
Okay, super. That sounds good. So if we draw that and it's one-tailed, and which tail are we working in? The left or the right?
Are we working with the right?
Okay, so because our alternative symbol is to
the
less
left.
than,
Okay.
yeah, we're down here. Okay, so the bottom line is Lexi is on definitely on the right track. This is our do not reject. This is our rejection region. Okay, and then how do we determine this value right here? We go to our hack table.
Yeah.
And that value is, and we're using a level of significance of 0.01. So that value is going to be a negative value. And what is that? We use the value of negative, I just want to make sure.
2.33.
Okay, that is correct. All right, so we're comparing these two values. And our decision rule is if our Z-stat is less than negative 2.33, we would reject the null. So Cynthia, do we reject or fail to reject the null?
Since it's less than 2.33, we would fail to reject.
6.28 is less than negative.
Oh, we reject.
So what do we do?
Reject.
All right, so 6.28 is a value way out here. Okay, and negative 2.33 is over here. So if our Z-stat fell in this area here, we would reject it. But because it falls way over here, we do not reject. Does that make sense?
Mm-hmm.
All right. I like that shirt. I couldn't see you there for a second, but anyway. Okay, so we fail to reject. All right. Does everybody see that? We got a Z-stat. We're working a Z-stat because we're dealing with a population proportion. And when we're doing that, we always roll with Z. Like Lexi said, we're doing a critical value method, so we construct our rejection region and our do not reject region. We have a one-tailed test, so our rejection region is going to be the left tail because that's where our P-pop is on our alternative hypothesis. We get 6.28, and that is greater than this critical value here. And so we fail to reject. Okay. Any questions on how we got to this point?
Yes. How did you get that negative 2.33?
Okay. So we get this negative 2.33 by bear with me 1 second. Okay, we have this table here. All right. We have our hack table. And for our one-tailed test, we're using a level of significance of 0.01. That's in our narrative. And we go down here. Now, with a one-tailed test, it's not going to be both positive and negative. It's only going to be one value. And because we're operating in the left tail, it's going to be negative. So that's why we would choose negative 2.33. Does that answer your question, Greg?
Yeah, I just forgot all about that table. I still have yet to make a make a study sheet for the exam.
Okay, that's all right. Okay, so that's how we got that. And plus, Tim told me what the value was because I can't read it off my sheet because my eyes are terrible. All right, so we failed to reject. So what does that mean in the context of this problem? Brianna, what do you think?
In the context of the problem, would you, hold on, I'm sorry, I'm just trying to, it's not accepted? I'm a little confused.
Okay, so we fail to reject the
Right.
null hypothesis. Okay, so Batman was wondering if less people in Gotham prefer wild than the global
So,
population,
no,
he might have
because you
more time.
rejected it.
So, but we failed to reject it. So
then wouldn't his hypothesis not be true?
well, yeah, I mean, because we failed to reject. So what does
Right.
that mean?
That means that more residents may prefer wild than what Batman suspects?
Right. And so then what does that mean?
That he has to retest his hypothesis?
Yeah. And even simpler, it means he doesn't have much time. He doesn't have much time at all. He's got to move fast. He was hoping that not too many people like it or use it. And so therefore he'd have more time. But because he was wrong, he actually has less time. He's got to move even faster. Okay. So that's what the context of the problem means. Okay. So let me get rid of all this stuff and let's focus on this one. So if Batman used his sample proportion to construct a 99% confidence interval on what the population mean is, what would that confidence interval be? So let's see, Matt, why don't you just start us out? How would we approach that?
Not sure. I'm guessing there's an equation. Can't think of it though.
Okay. There is an equation. That is true. What do you think, Jennifer? How would we start with that?
So we would use our confidence interval equation, P plus or minus Z, square times the square root of P times 1 minus P over N.
Okay, super.
I have a question real quick.
Mm-hmm.
So regardless if this says sample or not within, when it also mentions confidence interval, are we always going to go to that confidence interval regardless if it says sample or not? Because like I was just a little confused on if we were supposed to go to a sampling equation or to a confidence interval equation.
Yeah. So, Tim, if it's asking for a confidence interval, then we want to generate a confidence interval.
Okay. Gotcha.
That's what I mean. I don't. That's pretty like red, big flashing neon sign. Hey, do a confidence interval.
Gotcha. All right. Thank you.
Because he has a sample proportion.
Mm-hmm.
So does that answer your question?
Yep. Yeah. Thank you.
Okay. So
I also
Jared,
have a question.
yeah.
I was just wondering if it was possible if you could like compile like all the study materials into like one section on Canvas, because going back to that last problem with the critical value table, I'm just having trouble finding that. So.
Okay.
I was just wondering if it would be possible to like put all the study materials into like one section.
I'll see what I can do.
All right, thank you.
Okay.
Just a
All right.
suggestion.
Okay, so Jared, how do we get started with this? What is P equal?
That's going to be 0.45.
Okay, you think it's that?
Well, that's
Now,
we're talking about population proportion, right?
well, remember we do confidence intervals for one of two things. We do confidence intervals for population proportion, and we do confidence intervals for population means. Now, to do that, kind of like what Tim said, we need the supporting relatives to generate those. So we'll need a sample proportion to generate a confidence interval for population proportion.
Okay.
All right. So what do you think P is down here?
0.76.
All right. Very good. Okay. And then if that's 0.76, then that's going to be 0.76. All right. And Trent, what is N?
It's the 100.
Okay. And Tim, what is Z in this case?
Wouldn't we have to go to the shortcut Z table? So to find the 99% confidence interval, that would be the 2.58.
Okay. Tim is correct. Okay. So remember, we used 2.33. Now, this is entirely different. And Tim is referring to our confidence interval shortcut table. All right. So we've got to have that handy. And like Greg asked, I'll see what I can do about consolidating things from where they are right now. Okay. But that's, again, one of those things you want to do between now and next week is get your inventory, your stuff together so you know what's what. All right, so once we figure all this out and do this math, what's going to be in the middle, Megan, once we write this thing out? What's going to be in the middle of our confidence interval?
We're going to put 1 second.
Okay. I'll give you a hint. It's going to be one of these two dudes that's at the top of the screen over here. Of course, my thing went away.
It's gonna be P-pop.
Okay. So for me to write this out, it's going to be P-pop right there. Eric, what do you get any? Let's see. I'll just do this. This is going to be greater than or equal to. And then on this side, this is going to be 0.87. And on this side, it's going to be 0.65 if we rounded to 2 decimal places. Okay, so this right here means that Batman's estimate for the population proportion of people that prefer Wild over other brands of hairspray is somewhere between 0.87, 87% of people in Gotham, and 65% of people in Gotham. So that means he's got to hustle. He's got to move fast, because for the folks that are using hairspray out there, there's a lot of them, according to this sample. Now, you could say, well, that's only 100 people, and there's a lot more in Gotham. That, so if he collected more data, it could turn out that, less people. But that's actually not true, because we know that when sample size goes up, this value here will become greater, and this value here will become less. That's central tendency. So Batman knows that just based on this confidence interval alone, that he's got a lot of work to do if he's going to contain this spread. Okay? Questions on anything we did? Okay. Why is that there? I don't want that there. Let's go down here to pick your poison. Let's go to quarantine. Okay. Let's take a look at this. Just trying to manage a couple things at once. Okay. Batman believes that the poison within Wild adversely affects people by increasing their reaction times to a whole bunch of things, whether it's an oncoming car, someone trying to mug me, all these types of things. So if this is true, the poison has the potential to cause a lot of large scale chaos, because the slower I react to things, the more, I could find myself in bad situations, whether it's a car coming at me, someone trying to attack me, that kind of thing. So Batman wants to see if the reaction times have become greater than 0.95 seconds. All right. So once again, it's time to construct a null and alternative hypothesis. Okay. So what do you think, Thomas? What would be our null and alternative hypothesis?
Actually, here, let me look at mine. I can't read that screen. Let me take a look here. Quarantine. It would be off the mean. Measure their reaction times. Standard deviation. Let me figure it out here. I'm actually not too sure.
Okay.
Yeah.
What do you think, Brianna?
I would say that it's okay. So okay. So greater than, is it the mean? When it's 9.5, would you do 0.9? I'm trying to think because I'm not quite sure how you do it when there's already a point in it. 0.905. No, because that would be 90.5. So it's gonna be. Is it gonna be less than on the? Not the alternate. Less than or equal to, right? And then just greater than.
Okay. Looks good to me. And over
I'm
here,
just
we're
a
gonna,
little thrown by that point in the 9.5. Do you just keep it like that because it's not a percent?
well, this is an average, so we don't need to do anything to it.
Oh, okay.
So, 9.5 seconds, if I, if I throw a bunch of stuff at you, if I surprise you and I take all these measurements of how long it takes you to react, and then I take the average of that, I might get something less than 9.5, but I might get 9.5 seconds. So I don't need to do anything to this. This isn't a proportion or anything like that.
Okay.
Okay. So this is correct because he believes it. He wants to see if it's become greater. He first has to disprove that it's not less than or equal to. Okay. So this is our correct setup right here. Now let's see. So he's got a sample here. We'll come back to that. Let's look at this. So we have our null. He wants to be very sure of his hypothesis test claims before he calls for a quarantine of the Gotham Wild Distribution Center. Okay, so let's imagine this. There's this distribution center within Gotham of Wild. They've got all these bottles of hairspray. There's all these workers who work there. There's people and money tied into this. And Batman doesn't want to look like the boy who cried wolf by getting that area quarantined. Okay, so he wants to be very sure of whatever the outcome is of his hypothesis test before he goes rushing down there to call for a quarantine. So Alyssa, should he use a significance level of 0.1, 0.05, or 0.01? What do you think? Is Alyssa still with us? All right. What do you think, Jack?
0.01 since it's the smallest.
Yeah, because 0.01, that means the lower significance level he uses, the less possibility he'll have of an error. Okay. So his possibility of making an error is actually that. Okay. So he's going to use 0.01. All right. And he's going to use the p-value to conduct this hypothesis test. So again, I jump you from here to here. What you've got to figure out is the steps in between. Okay. So let's see. George, what do we want to do first? We have this over here. I didn't mention this. Sorry, George. Batman gets a sample, 35 residents who have used Wild, and he measures their reaction times. He gets a sample average of 9.95 seconds and a respective standard deviation of 1.2 seconds. So, George, what do I want to do next?
Solve for your T-stat.
Okay. And why do I want to use the T-stat?
Because we're doing population mean.
Okay. Why else?
Not really sure.
Okay. You're on the right track. Remember, just because for any of you, just because I asked you a question doesn't mean that you're not correct. Lexi, what do you think? Why might I want to use a T-stat here and not a Z-stat?
Because it's a sample standard deviation.
Okay, this is a sample standard deviation. Lexi is correct. Do I have a population standard deviation?
No.
No. You read over this. I do not have one up here. Okay. And so because of that, and this is also kind of a hint here, but that's not, I have a sample standard deviation. I don't have a population standard deviation, so I'm going to use t-stat. Okay. So Matt, what's my t-stat? Where am I going to put what, do you think? What am I going to put right here?
Is it 1.2?
Exactly. I'm going to put 1.2 right there. All right. What am I going to put right here?
You put the 9.95 second.
Okay. I'm going to put 9.95 because that's my X bar.
Mm-hmm.
All right. So if I put 9.95 there, what am I going to put here?
You put 9.5.
Very good. And that's my population mean. And then what else do I put on this thing?
Do you have to divide it all by the sample size, 35, right?
Okay. Super. Good job, Matt. And so out of all that is going to, sorry about that. My stuff disappears when I go over here. Out of all this, I'm going to get a t-stat of 2.21. And I'm using the the p-value method. Okay, so Max, what do I do now with that 2.21?
Did you ask me that?
I'm asking for Max. Is Max still with us?
Sorry, your connection went out. That's why I was out.
Okay, so Max, what do I do with this 2.21?
Well, that's your p-value now, right? So
That's my t-stat value.
or you can find the p-value from that.
Okay, so how do I do that?
I thought that t-stat is the p-value. That's why I said that.
So you think this is the p-value?
Now I'm realizing no, not. Plug that into a the t-table
How do I do that?
with or
Don't you find the degrees of freedom and then go to that?
Yeah.
Okay, so what's my degrees of freedom?
34.
Okay, so degrees of freedom is 34. Remember, I'm doing the p-value method. What do you think, Kendall?
This is where you use the Excel formula. It'll be t dis dot, and then this will be the RT.
Okay.
And then you put in the 2.21 and 34.
Okay. So it's RT because my alternative hypothesis has the population mean in the right tail. Okay. If I wrote this the other way, like this, okay, it's saying that we're to the right of that. Okay. And then whenever we have that greater than, we're to the right. This is the same thing. So conceptually, we're trying to see if we're over here in that right tail. So we put that in here. All we need to do is put our degrees of freedom. With the p-value method, we don't need to go to the t-table. We can use that function there. Okay, Kendall, do you have that value handy of what we get out of this equation?
I do not, but if you want me to find it real quick, I can.
I've got it. Thanks, though. I just wanted to do this before blanking out my screen. So I get when we put this in, we get 0.01665. So Hannah, do we reject or fail to reject the null hypothesis?
I think it's fail to reject.
Okay, Hannah's correct because this now is our p-value. Okay. And just right there, we can see that we always compare the p-value against our level of significance. All right, so since our level of significance is 0.01 and our p-value is 0.01 and some change, this is greater than that, which means that we fail to reject. Okay, so out of all that, Jared, what do you think? What does that mean? If we fail to reject this within the context of the problem, what does that mean?
Then it means that people aren't rejecting or aren't reacting as fast to the effects of wild as fast as he was hypothesizing.
Actually means that reaction times haven't gotten greater. They're still less than this amount. Okay. It's a little confusing because the larger this becomes, the slower reaction times are. But remember too, he was interested in quarantining the distribution center. So because he failed to reject his null, he really can't go running down there asking for a quarantine of the distribution center. Okay, he really can't make that case that we should do that. Okay? Questions on what we just did? All right. I think we have time for one more. Let's go to what's behind door number 3. Okay, Batman has intercepted a shipment of wild bottles en route to G Story, which is the local news station in Gotham City. Batman estimates that the Joker has the capability of infecting up to 45% of all of the wild bottles in Gotham. Okay, so of all the wild bottles in Gotham, and he doesn't exactly know how many there are, but he estimates that the Joker has the ability to infect up to, but not more than 45%. So it could be 45% or less. So there's 3,000 bottles in the shipment that he seized, and the newscasters are giving him a hard time because they're insisting that they need those 3,000 bottles to continue operations, because newscasters really revolve around how good they look. That is part of the job. So question number 1, what is the probability that 50% or more of the shipment's bottles are poisoned? Okay, so let's see here. Eric, how do we approach that problem?
Would you set up the equation like we did previously, where you would take 0.5 and subtract it from the 0.45 that were given in the problem?
Okay, so all right, and keep going with that.
And then that would be divided by the square root of 0.5 divided by the sample size, which is 3,000.
Okay. All right. Everybody see that? So we got 0.5 for our P, because again, don't confuse that with a probability. We're actually determining a probability. 50% in this case, this is a proportion problem. All right. And this is actually a sampling proportion problem. Okay. So in this first question, the sample size, like Eric identified, is 3,000. Okay. So we're trying to figure out what that probability is. So let me look at what that equals real quick. All right. So I get that this all equals 5.5. All right. So Jack, what do we do with that 5.5? What is that 5.5 to begin with?
It's gonna be what? Z-stat?
Yeah. So it's a Z-score, which is pretty close. Okay. And since it's a Z-score, that prompts us to do something with that.
Yeah. Don't. Oh man. What do I do with that? I'm not sure.
Okay. Jared, what do you think? What do we do with this?
Are we gonna look for a proportion?
Okay, so we have a Z-score. We have a proportion. We already put that in there. Now we have a Z-score. At the end of the rainbow, we want to answer what probability that 50% or more. So we still have some more steps to do to get a probability. So when we have a Z-score and we want a probability, how do we convert a Z-score into probability?
Don't we go to the normal distribution table where like you go to find the Z and then find the probability that way?
Okay, super. So where's 5.5 on the normal distribution table?
I don't have the long table, so someone else take it away.
Okay.
It's way up at 0.9999999.
Yeah, because the table only goes to like 3.6, right? Okay, so is the probability that 50% or more is 0.999, or do we need to do something else?
Well, do
You have to
subtract
do
it
the
from
1
one.
minus.
-1.
Yep. So whenever we have an or more situation, we got to do a 1 minus. And that would equal 0.0001. Okay, so that's the probability. And then for this next one, I'm just going to go through it. So let me blank out my thing. So newscasters are demanding 30 bottles to conduct tonight's show. What is the probability that 9 or more of these 30 bottles are poisoned? Okay. So really it's the same setup. The thing that's different is we have a different N. This time we have an N of 30. Okay. So the first thing we need to do is figure out what P is, but our setup is still the same. Kind of like Bob Seger. So we're still going to use this formula. Okay, and we're going to take the results of this formula to turn that into a probability. So we're going to take our P is equal to 9 divided by 30. And we're going to take that minus the 0.45. Everything else in the denominator is the same, with the exception of N, which is 30. And in terms of what that equals, that gives us a negative 1.65 for a z-score, which corresponds to a 0.049 on the probability table. But the problem is that that's or less. We want or more. So again, we've got to take a 1 minus. And that would equal 0.9506. Okay, so it's actually a very high probability that 9 or more within that sample of 30 are infected. Okay, and then the last question is more of a conceptual question about one of the guys at the station says, well, exactly 1350, meaning 50% of the 3,000 are contaminated. And really the answer to that is William is not correct, because he's taking a deterministic approach to a situation dealing with probability. I mean, there's a probability that every one of those bottles is infected. How high is that probability? It's actually very low, but it still could be. There's a probability that exists. So it isn't exactly, whenever we have probability, things aren't exactly one number. And then more technically, when we get the probability of that specific number out of the shipment is actually low, and probability we deal with ranges. So I just kind of asked this question. I'm not going to ask a question like that specifically on the exam. It's a lot more conceptual, but I was kind of trying to reinforce the point that we just don't take 0.5 and apply it. You know, we don't just take 0.5, for example, and apply it to 3,000 and say, oh, well, 1,500 are going to be infected. That's not how we do these things. Okay. Questions on anything we've talked about today? All right. If there are no questions, and again, I would encourage that if you have questions between now and the final, that you come up on the net. I don't quit working on Friday just because you don't have a reading day rep. You still know how to get hold of me. I just wanted to make some closing comments to close the course. I've enjoyed this time with you. Let's talk about you. So at this point, you are a bad mother, meaning you've got some mad skills, okay? And you should value those mad skills. You should use those mad skills, not just for the final, but beyond this course. And because you have those mad skills, you should not take any BS. After this course, you're going to hear people say statistics and use statistical things and try to deceive you with statistics, and you should not accept any of the BS. You should call them on it, not just to disrupt conversations or things like that, but there's people every day who are trying to deceive you with this stuff. All right? So don't tolerate it. Have confidence in your mad skills, challenge them on that. It'll disrupt their flow. And at the same time, you can go back and approach things scientifically. All of you did the Way of the Warrior project. I enjoy the Way of the Warrior project. The key of success, not only in this course, but in college itself, in lifelong education, is to take away what is useful to you and add specifically what is your own. All of you took the Way of the Warrior and the knowledge that you've gained in this course and applied it towards something you were interested in. And that, the more you can do that, the more education transforms from work into passion. And once you can do that, the more you can do that, the more I think fulfilled and successful you will be in your life. So I encourage you to always do that, not just with D3M. Now, many of you might have came into this course not wanting to do it, maybe even scared of it. Maybe you're scared right now, you're scared for the final, and all of that is understandable. But remember, it's never as bad as you think it is. Pet the bunny. Don't be afraid. Turn that fear, the only thing you have to fear is fear itself. Turn that fear into positive energy. Take action. Get your book out. Get the internet out. Pull up your formula sheet. And what's the worst thing that can happen? The bunny will bite you. But it can't be that bad. The world is not going to end just because you pet the bunny. Let's talk about the short term. From here on out, it's all about strength through repetition. So rep out with your bad self. Okay? Don't just do trash reps, do quality repetitions. Maybe you do forced repetitions, but do the repetitions. Strength is built, particularly in D3M, through repetition. So I encourage you to value and enjoy those reps, man. Now, in the short term, you're probably going, hey, all this is great and motivational, but I got like 5 finals that I got to worry about. Stay in the fight, believe in yourself, and rock out next week. I know that you can, and I look forward to your success. And on that note, beyond this course, let me know how I can help. You are the future, and I mean that, okay? Our world is in challenging times, to make an understatement, and it is you that are going to lead us through those challenging times. I'm not letting myself off the hook. But you're the ones who have the fresh, who have the bold ideas, and you have the energy and the passion. So I'm sitting at home with my flag of your fan club, waving it for you. Let me know how I can help. Now, I know what you're thinking. You're going, well, you can help by not having us have a final. Yeah, that's not the kind of help I'm talking about. But if there's a way beyond this course that I can help you, come up on the net, shoot the signal in the sky, and I will see how I can help you. I actually look forward to that, and I look forward to your success. So with that, I will see you. If I don't talk to you, I will get your exams next week, and I look forward to seeing you on the street. As always, I will stay on the call until we clear, unless folks, if folks want to hang out and ask additional questions. Otherwise, have a great week. Have a great week next week, and we'll see you soon. Take care.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Are you going to post the answers for the Joker's Wild just so we can kind of compare?
For a small fee. Yes. Yes, I am. I'll have those out sometime today. If not today, early tomorrow, but I will definitely have them out.
All right, thank you.
Yep.
Tomorrow's you're going to be online during reading day, or is that tomorrow?
So I have times. If you want time, you can sign up.
Okay.
So I have some times available. But I am going to be online during the times that are booked. I'm going to be talking with folks. So
Okay, cool. I'll look at it. Thank you.
okay. All right.
Have a great day.
Yep. You too, Max.
Would you say that you would put in the participation grades before the final, or is it all going to be put in after we finish the final, and then you'll put in everything else?
No, they'll be up tomorrow.
Oh, bet. Okay.
Yep.
Thank you.
Yep. You bet.
I had a quick question on Wild World. When we got the Z-stat of 6.28, I got lost there because once I solved the equation in Excel, I got 0.049749.
Let me see if I can make this bigger. You got, so here's what I got for the Z stat. Is that what you're talking about, Megan?
I was muted, sorry. Yeah, that's what I'm talking about. Looks like I got lost at the last z-stat denominator.
Okay.
So that's, I have 0.0497, but then I got confused.
Okay. So did you get this for the numerator?
Yes, I got 0.31.
You got 0.31, and you got that for the denominator.
Mm-hmm.
Okay, so did you divide the numerator by the denominator?
Oh, I clicked the wrong cell.
That's all right.
Okay.
That's what this is all about. I mean, we want to screw it up now so that, not screw it up, but you know what I mean?
Yeah.
We want to make those mistakes now so that we hopefully won't make them, you know, when we have less ability to recover from.
Yes. Okay.
So,
awesome.
But the good news, not a major thing. It's a computational error, not an understanding one, from what I'm gathering, right?
Yes, I clicked the wrong z-stat denominator or whatever. I don't have them labeled, so that's probably where I should go back and make it organized so I don't click the wrong one.
Yeah. And just, I'm trying to think other ways that you can kind of bulletproof yourself.
I think when I write it out on paper too, and then I don't get confused with the columns in Excel, but I don't know. We'll see. I'll keep it organized, keep practicing. So,
well, it's again, just because I write it like this, and actually when I give you all the answer key to this, I'm going to write it out. And that's for a couple reasons. One of which is if I gave you this, I'm afraid that some people would just kind of look at this and not know what to do with it. Or it would be too, it's not user friendly. I'll put it that way. So when you see it and I post it later, it will be handwritten.
Okay.
Kind of like I've done in the past or done in a handwritten way. But the bottom line is, Megan, if it works for you to handwrite it, then handwrite it.
Okay.
Okay. I don't care if you handwrite out all your work next week and then you take a picture of it and send it to me.
Okay.
As long as I can read it.
Sounds good.
Okay. So
right.
do what works for you.
Okay. Thank you.
All right. Cool. Take care. Thomas, we good? You just hanging out?
Yeah, I was just listening in. Have a good day. I'll talk to you tomorrow.
Okay, Thomas. Take care.
All right. See ya.
Talk to you tomorrow.